Hello, in some tables you would like to reuse some of the declarations of the columns, giving them another names. Like for example, almost in every table you would have a primary key which is auto-incrementing, which will have a serial type, data type of the SQL. In PostgreSQL, you would like to give it a different name, not exactly specifying that it is ID, like we can just print here user ID. And this is a bad way in two ways, understandings. So firstly, it is a reserved name of the Python language. So you would not like to just print it ID, because even if it's attribute, it is reserved by Python language. You would not like to use as it is, as ID. And also in SQL queries, sometimes your tables will have overlapping names of their columns. And even that ORM is making this convenient for you on the surface, so it will put a table name and then the column name, so you actually could have repeating names of the columns. Sometimes when you go to the actual database and you would like to write some query, it will be beneficial for you to use something like this, user ID, or not in this case, but for other tables you would like to have order ID, product ID, etc. And all of them will have an integer, a serial data type. They will be primary keys. So they basically will have the same declaration in our class. And we would like to reuse this thing. And in order to do that, we can specify them as global variables, kind of constants, if you wish. For example, you can use them for some constraints like foreign keys or primary keys or any other columns that you want to reuse in different tables. For example, integer primary key, which will be a serial data type. We can make it equal to annotated class. We will import it from typing extensions. I suppose you can see in the documentation of SQL Alchemy, they importing it from typing extensions. They import annotated. You can specify an integer primary key that we are going to reuse. And here they have another example of foreign key. And let's just type it. Annotated. We imported it from typing extensions. We specify which type it is. It is an integer. And then we specify how we are going to declare it. And here we put mapped column. Again, we declare the same thing that we have written here. But since it is an integer which has a serial data type, we can just put serial and import it serial. Probably there is no serial data type in the SQL Alchemy. So we can just use integer. We import it from SQL Alchemy. And then we specify that it is a primary key. And I believe that there is another argument which called auto-increment. We'll use the auto-increment feature of our database systems. So for Postgres, it will be converted into serial. But I believe that it is not important here to specify it, because by default this is not nullable column, and therefore it will convert it into serial by itself. And apart from the integer primary key, we can also create a foreign key for our users, for our user table that we are going to reuse in other tables by relationships, by foreign keys. And we can name it like user fk, which means foreign key. We use annotated integer mapped column, and then we specify that it is a Bing int. It references Telegram ID. It sets null if the user was deleted, and it might be nullable, but it is not what we want here. So we will have this user fk variable for us prepared to use here in mapped annotation. Let's also prepare a string value, string 255, which will mean that we want to have this varchar of length 255, which is not nullable. And we can now redefine our user table. Let's comment it and create again class user. And you can see it's not actually correct. Yeah, it's not correct at all. We still need to have mapped annotation in here. We still use integer, and just for Telegram ID, we need to specify big integer. We can also specify description, but I don't want it. Yeah, so Telegram ID, no changes. Then for full name, we can use this full name mapped, and here we just put str255 because we know that full name is not nullable and will have a length maximum 255. For username, it is not so. We can try to do this, to convert this in optional type. And I believe this might work, because by this typing, we specified that the username can be nullable. Language code, again, just for demonstration purposes, the length could be smaller, but we use 255. The refer ID, you can see optional, mapped, but not int, but user fk, like that. So we can see even our table of the user became much more concise. Probably much more readable, provided you know what these all mean. Here our user was defined, but we want to define other tables as well. Let's assume in our project we will have another tables for orders, for products, and a many-to-many relationship between orders and products. So there will be many different products in different orders, so they will be overlapping. Firstly, let's look at our tables defined in raw SQL. So for example, products, it's a very simple table, product ID. You can see I'm not specifying ID, I'm specifying product underscore ID. It is serial. Like I said, it's auto incrementing, it's primary key. Then the title of the product, again, variable character. We will be reusing this str255 annotation. Then we will be having description of our product and created at, but we also can reuse the timestamp mixin to create an updated at column as well. Let's see how it will look like in SQL Alchemy. It inherits from base, timestamp mixin, table name mixin, product ID, which will be using integer primary key. And here we don't need to restate again the mapped column. This statement will be enough. The title, which is str255, that's right. Description, we can just put mapped str, so it will understand that we want text in here. And it is optional, yeah, it is truly optional. So here how our product table looks like. We can move to orders table. Let's define it. It will have order ID, which is again serial, primary key. It will have user ID, big integer, not null. So every user will have an order, and this will be a foreign key as well. And be aware that now on delete, we will be using another behavior called cascade. So if the user was deleted, so the orders will be deleted as well. We can modify if we want it. And also the created at and updated at as well. Let's create a class, order ID, user ID. So like that. It just has 2 attributes here, but we can access other columns as well. So like created at and updated at. We can also put some information about the order here if we want to. We can have a link to the address of the user that will be connected or related to this order. So we could have another table, but we won't do that. And let's create a many-to-many relationship between order products, because you can see that order does not contain any products by itself. And the order products, another table, will be containing them. So it will be order ID, the foreign key to the orders, the table orders, product ID, again foreign key to the table products, quantity, if you want to put many products in one order, and we can put any information more here. For this table, we are not exactly required to use the timestamp mixin because we know the time when the order was created, and that's pretty much it. We don't usually need to know when each product was placed in that order, but you can do that if you want. Let's create the table that will merge our 2 tables by many-to-many relationship. So it will be order ID mapped integer primary key. Not correct. We would like here to have actually a mapped column because we need to have a foreign key here. So it will be an integer, foreign key to orders, on delete cascade, primary key true, yes. The same thing we want here for product ID. You might remember that if you want to reuse these foreign keys, you can also create an annotated objects like that, but I'm not going to reuse them. And the quantity, which is actually not nullable, correct, and has a type of integer. That's correct. And now we have created 3 tables, well actually 4 tables. You can also be adding a relationship, as I said, like specifying an order here, order, which will be a relationship to our order, and a argument backpopulates the order products, so this table. And the same way we could have a product relationship, and then we must put in those tables the relationships, back relationships as well. So we can access the products from an order more easily, but we are not going to do that here to make it less complicated. So yeah, by now you might have learned how to create in a more advanced way all your tables, provided you are using at least 2 or 3 normal forms. And now you know how to map them.